Okay, my name is Sarma Susarla. In this presentation, I'm going to give our approach for software assurance in ISS. Now, how do I click to go to the next chart?
I can do it if you want.
Okay. I used to have, yeah, I see cursor. Okay. We have a lot of information here, so it's not possible for me to go through all these busy charts. So I'm going to summarize our concept, and if you have questions and if you want to have further discussion, we can do that in the breakout session. Okay. Now, IV&V, we have been doing IV&V for the last 18 years. Software architecture is and design is very mature, but still, you know, there are software changes that are taking place, and some changes are very significant. For example, you know, new releases are being developed to support visiting vehicles and implement international docking. So we have roughly about 23 in scope CSCIs that we do IV&V on. Of them, you know, roughly you can expect 7 to 8 CSCIs or even more. In any year, you know, we'll be doing life cycle support. So even though it is in sustaining phase, we are doing development and we are going through the entire life cycle process for each CSCI. Okay. Now, we have been generating software assurance reports all along. Whenever a milestone review completes, like technical design review, TDR, or test readiness review, TRR, we're going to develop a technical report. And in that, we do have assurances that the software is mature enough for the next phase in development. So, but in this approach, what we are doing is we are integrating all these individual assurances into a grand assurance case network, and going to use that as a substitute for these individual technical reports. Okay. Next. Now, in this, the approach for these assurance cases would be that we are going to use the life cycle model. Okay, so the life cycle activity that is being done will be mapped into different assurance cases. Example, so each life cycle development item, when it is completed, then it will be an assurance case. It will be a claim. Example, requirements development completion, that will be a claim, and code development completion, that will be a claim. So we're going to map the individual development milestones into this assurance case network. Okay. Then for reporting, and we'll be generating evidence all along, because we will be participating in ongoing life cycle, the various development reviews like requirements review, code review, and test reviews. So we will be generating the evidence, you know, for these assurance cases. So we'll be using BIVAR. BIVAR is the biweekly activity report that we generate, and we'll be using that report as a mechanism to report the evidence that we gather, and also report that if an assurance case is completed and it is realized. Okay. And next item is, I think I basically covered this. So much to say here. Here is the life cycle timeline. Now, first we have a content review. Before I talk about content review, let me say that we have a PVCS in ISS. This is a problem database. So this contains various items. Each item is called software change request. So if you need new functionality to add to one or more CSCIs, there will be a software change request. In addition to that, you know, there will be a SCR, software change request is abbreviation is SCR. There will be SCRs for product improvement, you know, and also there will be SCRs, you know, if there are problems, behavior problems for the CSCIs. So we'll have an entire database of what to do next for this release. Okay. So at content review, what we are going to do is, we know what the mission requirements would be for the CSCI. So each CSCI support is on orbit for roughly maybe about 12 months or 1.5 years. So we know what the mission requirements are. And so we are going to select the SCRs from this database to support this mission. And also, we are going to select some critical problems or product improvements that we want to implement for this release. So that is the content review. Excuse me. Then we have a so at the end of the content review, we'll know what SCRs are going to be implemented in this particular CSCI release. So following that, then we'll have a requirements development, which will be ongoing, and the requirements change correspond to each SCR are captured in what is called a requirements change sheet. So there will be a RCS, this is called RCS. There will be RCS review process that will be going on throughout, and IV&V will be participating and providing issue feedback. This is where we analyze the requirements for Q1, Q2, and Q3. Right? Then we'll have a TDR. So we'll take TDR. TDR stands for Technical Design Review. So this compresses software requirements review, the preliminary design review, and critical design review, all lumped into one. So this is what we have for the sustaining CSCI development. So for a TDR, we'll have essentially all the requirements are completed, development is completed, and we have also the design documents are updated to match those requirements. Then following TDR, then code development will start. Okay. Now in the code development phase, we will have for each SCR, if it involves code change, the code will be developed and it will be unit tested, and they will take a review. We'll be participating in the review and we'll be analyzing the code, and this is where we will be looking at analyzing the code for questions 1, 2, and 3. All right. At the same time, in parallel, we are having test design development and test implementation process going on. So the FQT tests that are necessary to test the release, the development of them will be going in parallel, and we will be participating in those reviews and providing issue feedback also. Okay. Now, at the end of it, okay, now when all the FQT tests have been developed and they were dry run and they are ready to go, we'll have a TRR, that is test readiness review, which is almost merely a formality. Following the TRR, we'll have FQT actual testing, formal testing. After the FQT is completed, then we'll have integrated testing. This is what we call stage testing. In stage testing, the CSCI is integrated with other CSCIs that it will be coexisting with on orbit, and the CSCI will be tested in an integrated environment. Okay, so we'll be participating in those reviews and also providing issue feedback. So now, following FQT and following the end of stage test, so this period roughly could be about 4 to 6 months. New problems, there will be also other operational tests that will be going on, and the new problems will be discovered, and those problems will be going into the SCR database. In parallel with this, there will be a SCR disposition process that is taking place. They're going to look at the SCR and see how important it is, how bad the problem is, how important it is to fix the release for this problem, and they will be approving changes to the software in the form of, let us say, code patches or PPLs. PPL is adaptation data, that they may change the adaptation data to fix the problem. So that SCR disposition process will be going on during this period. Okay. Now then there is the final review, the software transition review. This is where we look at the entire life cycle process for the CSCI. We look at all the open issues that may exist, and we'll see if they will impact the software operation for transition or immediately after transition. Okay. So when we do not have any issues that will impact the software transition, then we'll say the CSCI is ready for on-orbit deployment. So that is briefly what this life cycle process is. So next few charts, they describe each individual reviews. So I basically covered that. Now here, this is the heart of my presentation. So the assurance model for somebody says it should be called assurance design rather than model, whatever it is. So this assurance design will have a generic component. Okay, so the entire network will be a generic network, and each claim and subclaim in this network will be a life cycle development activity completion, like requirements completion or code development, etc. Okay. Then for each CSCI, this generic model will be instantiated, and any changes that you may have to make for the CSCI, they will be made. Okay. So then we'll have a generic evidence reporting mechanism. So since we do ongoing reviews, so the various claims will be realized as we collect evidence. So there should be some mechanism to report that evidence instead of waiting for till the end of the life cycle. So we use the BIOR mechanism to summarize the evidence and also summarize the activity that we have performed to generate the evidence and report this in our BIOR. Okay. So then, for the purpose of analysis, we will have a technical reference for the various adverse conditions that we'll be looking at. Okay, and also we'll have technical reference for any undocumented CSCI behavior and that we need to know about that is not really clear from the artifacts. Okay. Then we have PAL assets, which give detailed guidelines from an ISS architecture and design perspective on what to verify and how to verify for requirements, design, and code and test. Okay. And these assets will integrate the adverse conditions also in those guidelines. Okay. Now here is the structure of this. The assurance model is a really tree structure rather. The topmost claim it represents the final assurance claim, which says that software is ready for on-orbit deployment. Okay. Then you will have a claim statement, and the second level, will have various subclaims, and then we'll have a third level, which will have again various subclaims. Each subclaim, representing some life cycle development activity, and the last level will be basically a claim that we make on the basis of behavior analysis. So, like analyzing the product for IV&V questions. So the first two levels will be mostly life cycle based claims, and the last level, the lowest level, will be behavior analysis based claims. In general, that's how it will be. Okay. The evidence that we'll have for these will be the SCRs we looked at, the RCSS, that is the requirement change sheets we looked at, and also the tests we reviewed, and any IV&V issues we generated during this process. Okay, and also another evidence is our statements in BIOR saying that we have completed this work and this requirement, this assurance state is realized, and making that assertion. That will be also part of the evidence. Okay, and the argument will be that basically we are describing what we have done as part of our life cycle analysis activity to generate this evidence and to assert that this particular claim has been realized. Okay. Now here is the graphic. Here is the graphic that represents the entire network. We have the topmost claim, which is the goal of our life cycle activity. We want to be able to say that CSCI is ready for on-orbit transition. If it is not ready, we need to tell them in advance what kind of problems we see that will come in their way now, in that way, and we have done that before many times. So, so if you see this, this activity, in order to do this, there are many subclaims here. The second level, SCR content must be represent the mission concept. This is what we do in content review. And requirements are developed as per SCR content. Okay. And again, you know, underneath this, we have a subclaim that this is mostly a behavior-based claim, that is what we are saying. Requirements are evaluated for IV&V questions. Okay. So when we say the requirements development is complete, not only the process aspect of it and also the behavior aspect of our analysis must assess that, must show evidence from that. Okay. Similarly, we have design and we have the design activity and we have code development activity. Then we have FQT test, development and verification, and this has a lot of individual milestone development activities like test design activity and test script development activity, and also the regression test evaluation. You see, why we are doing regression tests is because the FQT is not a full FQT. There will be what they call delta FQT. They only test the changes and that are made since the previous release. In addition to that, you know, they will have a standard regression test that they are going to run. So we have to verify and make sure that the regression tests are adequate and they exercise the major portions of the software or the major functions of the software. Okay. So we have so many subclaims. The third level subclaims, you know, for the second level subclaim. Okay. Then the final assurance case is all CSCI. This is what we analyze for at transition review, which the claim says. Incidentally, the claim description here is abbreviated to fit in the box. Okay. So here, what the claim is, all CSCI issues that impact on-orbit transition have been addressed. So we don't have any problems, you know, in transitioning the software on orbit. Okay. Now, the purpose of analysis, as I said before, we'll have PAL assets, which are really extension of existing COM methods. These assets really give detailed guidelines on how to evaluate for requirements, design, and code and test. Okay. These are ISS design specific. Okay. So then the next thing is adverse conditions. The adverse conditions are captured in the technical reference folder on the ECM, and we're going to have in that adverse conditions also we will define what the acceptable behavior is. Okay, under adverse conditions. Okay, and these conditions again, you know, some of them will be applicable to requirements analysis, some of them will be design analysis, some of them design and code, and some only for test. So they will be marked as such in the spreadsheet. Okay. Now here is one aspect of adverse condition evaluation. When you are looking at requirements, and if you want to see that Q2 is incorporated in a particular requirement, which does happen, then when the Q2 aspect is, that is what the software is not supposed to do. If it is incorporated into the requirement, then you know that adverse condition is incorporated into the requirement, so it's no longer. Then from that point onwards, it becomes a Q1 analysis, which is what the software is supposed to do. Okay. Then the same thing with Q3 also. If some requirements do have in them integrated adverse condition response. So if this is what we are going to look for when we are doing evaluating for Q2 and Q3 during requirements evaluation, there will be some reasonable adverse conditions which need to be integrated into the requirements, and we are going to point out those, you know, during our analysis. Okay. Then there will be some adverse conditions. In fact, it is for Q2 and Q3, the adverse condition set is infinite. You know, it's impossible to define requirements for all these adverse conditions. So for requirements, during requirements analysis, we are going to look at what is reasonable, okay, to define. Then there will be a lot of adverse conditions, design related and code related, and there will never be requirements definitions for those things. And we'll be looking at those things, especially during design and code analysis, especially during code analysis. In fact, that has been a source of ISS problems in my all 18 years experience. There will be a lot of adverse conditions where that could happen and the code will break. Okay. So this is that, and there will, and also another point here is for the adverse conditions which are not defined in the requirements, okay, and which we could not evaluate just by looking at code analysis, doing code analysis. That will be subject for independent analysis and test. Okay, which we will take it up after the CSCI development is complete. Okay, here is a list of adverse conditions. This is again a partial list. You will see the comment for each adverse condition. There is a comment field. Maybe I should say instead of comment, some analysis guideline or something like that. It says what sort of things we should be looking at under each adverse condition and what could be the potential impact for those adverse conditions. So here we have adverse conditions, at different types. You have adverse conditions on the communication channel that could take place. And you have adverse conditions that could take place in the hardware and behavior. Okay, and you could have some adverse conditions as a result of software misbehavior. All right. And you could have also adverse conditions because of operator entry errors. Okay, that will they will generate adverse conditions also. There is another most important thing. You could have multiple adverse conditions occurrence. So there will be countless scenarios that one can look at. Okay, so these multiple adverse conditions, if they can happen, then they could, particularly, when you're talking about catastrophic hazards, ISS is supposed to tolerate two faults. So this is part of our analysis to make sure that multiple adverse conditions will not result in the losing a hazard control, which is catastrophic hazard control. Okay, so this will be the technical, the adverse condition database, rather sheet, will be used extensively in our analysis. Okay. In the next few slides, I'm going to describe a few typical the assurance cases, how they will be documented. So, for your information, rather. Okay, this is the requirements claim. Okay, this is the requirements assurance case, rather. So the assurance claim, this statement is required. Incidentally, this will be documented in Microsoft Word documents because that happens to be most convenient to document this. So the description says, the claim statement says requirements are developed as per CSCI SCR content and completed development prior to design and code development. Okay, so that is what we expect in this development life cycle. Okay, so the evidence. So here the evidence is all the RCSs we looked at, and all the BIVAR reports that confirms that our review issues were incorporated into the requirements, and also our review status that we reported in BIVAR, and at the same time our integrated or rather our formal statement in BIVAR when we say that this requirement development is completed and this claim is realized, when we make that formal statement, that is also, I would consider that as evidence. Okay. Then we have a subclaim here for this. This subclaim really, this is the behavioral aspect of the analysis. Requirement evaluation as per IV&V 3 questions. when all this evidence is met, okay, basically so this claim is realized, and instantly we have to clean up this evidence and make it. There will be some kind of duplication here. This is kind of a rough draft, so we'll have to clean this up. Now the argument basically here is that describes our IV&V activity, what we have done to ascertain that the requirements are developed. Okay. Then next. Now this is the analysis subclaim. This is to support the requirements claim. This claim says the description is the requirements adequately capture what the system is supposed to do, what it is not supposed to do, and how the system should behave under adverse conditions for defined adverse conditions. Okay, and since you cannot analyze them for all possible adverse conditions, so we have a caveat at the end saying that it's not possible to do for everything. Okay, then the evidence here is looking at the RCSs that we looked at and list of issues we generated, and also the usage of PAL effect, which ISS requirements review and analysis guidelines, which integrates usage of the adverse conditions during the analysis. Okay. The argument here is for this is each analyst is instructed to use the guidelines in PAL effect for requirements analysis. Okay. So each requirement is analyzed to match the concept in the SCR that drives the new requirement or change the existing requirement. Issues were submitted to the developer when the requirement is deficient from IV&V 3 questions perspective. The analysis will cover all aspects of IV&V Q1 and practical situations for IV&V Q2 and Q3. So that is the argument for that. Okay. Then now when I remember I said when a claim is realized, we will make a formal statement in the bylaw as part of the evidence that this claim is realized, and this will be a summarized statement that says that explains why this claim is realized. Okay. So here is so this our generic model. We have a template for each of those claims that need to be reported in bylaw when the claim is realized. Okay. So here in this I will read this. CSCI requirements development is completed and new requirements are captured in SRS version so and so in time. Requirements developed through so many RCS reviews. IV&V evaluated the requirements to ensure that they capture what the software is supposed to do as indicated in the respective SCR. IV&V also evaluated the requirements to ensure that as specified, the software does not do what it is not supposed to do and behaves adequately under adverse conditions as indicated in the ISS technical reference adverse conditions. Okay. So this is the integrated statement we will make when in the bylaw when a claim is realized. So for this claim, the other evidence will be attachments. This will be attached to the final technical report. So it's a table showing the SCR numbers, RCS number corresponding to the SCR and the review date, a list of IV&V accepted issues, and also for this particular assurance case, a table which shows for each SRS function how many requirements are changed and how many new requirements are added. Okay. Now here is another example code development assurance case. The claim description is code development required by the SCR content is completed. So actually this needs to be a little more elaborative, but essentially we should say the code development is completed and the code meets what is required in the SCR and also the requirements for the IV&V questions Q1 to Q3. So this claim the statement needs to be modified. Okay, evidence again, it's a similar evidence that I have reported in the case of requirements. It is what we have reported in bylaw, all the code reviews we participated, and our assessment of whether there is a problem with the code or not, and also this has a subclaim, code evaluation for IV&V questions. Okay. It's very similar to what we have in the requirements. So the argument again here will be very similar to what I have described in the requirement assurance case. It will describe, the argument will describe really how we generated the evidence and what activities we have performed during this life cycle process. Okay. Is report evaluation subclaim, it's very similar to requirements evaluation subclaim, so I'm not going to go into that. This is again code development claim reporting. This is again, we report when the code development is completed, when the claim is realized, then we report, this is reported after new flight code is released and IV&V has completed code review. Okay. So it combines the both 1.4 and 1.41, the main subclaim and its the lower level subclaim. So it combines, it's an integrated report which says that the code development is completed. Okay. And here are the details. I'm not going to go through them. It will be something very similar to what we have reported for the requirements. Okay, here is another claim for FQT completion. Close to how much time do we have? Okay. When the CSCI is formally tested, when the testing is completed, then we make this claim. Required CSCI behavior is verified through formal tests, and test anomalies were reported correctly in SCR. Okay, that's what we expect for this claim to be realized. Okay. So here we look at as evidence. We list all the FQT tests, their pass-fail status, and also the corresponding SCR that was generated, to report failures. Okay. And also evidence is our VIVA report indicating IV&V evaluation of FQT results. Okay. So there is additional information here. It's again very similar to what I have described for requirements. Claim. I'll go to the next one. Now this is for the reporting template. I mean, the FQT completion, the claim is realized. This is the report VIVA reporting template, and here we have as part of evidence the requirements for failed tests. And we list the requirement that has failed and the SCR that points to that failure. Then we have this is the last claim, that is the transition readiness review claim. Okay, so this is the most important claim. Okay. Now here we are making the statement that all software issues that affect on-orbit transition for the new release have been fixed. Okay. So there are no issues that impact the on-orbit transition process for the software and immediate functioning of the software after transition. So how do we make this claim? We are going to look at all the existing SCRs, undispositioned SCRs, or SCRs that are dispositioned to be fixed in some future release. Okay. And we are going to look at them, and we are going to look at what the problem is, and we will analyze and see if this problem will get in the way of successful transition and successful running of the software after the transition. So when we don't have any issues, then we say that this claim is realized.
Okay, Sarma, you've run out of time.
Okay, well, just 1 minute.
Okay.
So here we have at the end, we have this. When the life cycle is over, we are going to generate a technical report, which we are hoping will replace the existing technical reports that we write. Here in this technical report, we are going to have the overall claim network and a Word document showing detailed description, for each of those assurance cases, including the BIVAR statement that we made during the life cycle process, plus the various data attachments that support those claims. So the information for this report is accumulated throughout the life cycle. At the end, all we are doing is just putting these together. That's all I got.
All right. If there's any questions for Sarma, we'll take them over in the breakout session. And we are on a 15-minute break here in the main session.
I'm going to go to breakout immediately.
Yep, you can head right over there. And there's people actually headed there to ask you some questions. Okay?
So let me log into that.